So hello everyone, we are back with another live stream for 8 hours and today we'll be solving some blind 75 questions. So as we know that last time last stream we solved some pattern based question. We had a total of 14 patterns and in which we solved 7 pattern last stream and 7 pattern moves on last to last stream. And this stream we are going to apply those patterns on these blind 75 questions. So I'm planning of solving all the 75 questions, mm, which I think might be a good question, and I might skip very few basic questions which I think will be very easy, or even if you want I can solve those questions also. So I'll be solving all these blind 75 questions and yeah, finally we'll see how much progress we have done. Okay, so as you can see I have already opened a website where we have all these blind 75 questions with practice question and its solution together. So we have good number of questions present over here. So what I'm thinking of right now is picking one by one all the questions from low below. So I'll start from lower and we'll pick one by one all the questions and then we go to upper part and in that way we'll solve all these questions. Okay. Okay. So let me start my timer. So you can see that I'll be starting with a 50 minutes of coding and then we'll go for a short break of 10 minutes, and in between I'll take a long break, might be 50 minutes or 1 hour depending on the situation, I'll tell you. So yeah, so this will be my way to go for 8 hours coding stream. And I'll be explaining all the questions, and I also want you guys to solve with me. And if you want to solve another, if any other questions, you can always do that. Or if you want to do some other work in these hours, you are most welcome to do that also. Okay, so let's just start with let's start my timer and we'll try to solve DSA question. Okay, great, let's go. Okay, so this is my first question. First is sequences. Let's solve the sequences question and see what we can do. So it's saying search in rotated sorted array. It's a sequences question. Let's go to the link. Maybe I'll not use this platform, or maybe let's try with this platform also. I haven't done any questions. I haven't solved any questions on this platform. Design Gurus. This is the first time I'm using this platform. Let's see how everything goes. Just a second. Okay. So it is saying search in rotated sorted array. So we are given an array. We are given an array of numbers which is sorted in ascending order, which is already sorted in ascending order and also rotated by some arbitrary number. Find if the given key is present in it. Write a function to return the index of the key in the rotated array. If the key is not present, return -1. You can assume that the given array does not have any duplicates. So the array given does not have any duplicates and the array has been rotated by some arbitrary number. So you can see here the array is rotated with some arbitrary number. So in this case, in some arbitrary number, what we can do, let's take an example. This is my original array. If it is sorted in a ascending order, that is 1, 3, 8, 10 and 15. So this is my original array, and after sorting this, after rotating this array with some specific point, so I rotated it from here. So what we did, we cut this 10, 15, we paste it in the front, and then we paste this after that. So it is saying that we have rotated this array at some given specific point. Okay, now we need to find what is the key element present or not. If it is present, then well and good. If it is not present, then we need to do something. Then we need to return -1. Okay, it's fine. Now one thing that I can see over here, even if it is a rotated sorted array, if we go directly from start index till index in O of n time only, will be able to find whether we have that element or not. So that will give me a O of n time complexity. We'll just iterate over the array and check whether 15 is present or not. If it is present, then we'll return the index. If it is not present, we'll return -1. That's what the question is saying. Now, but this is a rotated sorted array, so the question expects us to use a log n approach. Means to reduce the time complexity from O of n to O of log n complexity. Now in this case we have to use binary search. Binary search is the only thing which can be used to manipulate this array and do the things according to our situation, whatever we want. Okay. So how to approach this question? Let's try and think on the approach part of this question. So one thing we know that this is a rotated sorted array, correct? Now a sorted array, this sorted array will always have a graph in some way, something like this. This might be one of the graph, or it might go somewhere this, something like that, or even it can go straight, no change, correct? But it can never go in the below direction because it is already sorted. So we know something. Now this is a rotated sorted array. In a rotated sorted array, what might be possible? Like we can see 10, 15 is somewhere here. 10 and 15. This is suppose my 10 and this is 15. This will be sorted. Now 1, 3, 8 is another separate array which is sorted. So suppose 1 no. 1 2 3. So this has 1 2 and 3. So we can see from here 10 to 15 is a sorted array, and 1 2 3 is another sorted array. Now we need to apply a binary search on these two halves. There are two halves now, means two separate sorted array are there, and in these two separate sorted array we need to figure out how to solve, how to apply binary search over here, correct? So in this, how we can do, how we can apply binary search over here, and we can find our key element on in login time. Okay, so let's assume uh, what binary search is. I think you guys must be knowing what actually binary search is. It's nothing but just will have a lower value here. If it is a normal array, we'll have a lower value here, a lower pointer here, we have a right pointer here, and we'll add we'll find mid with l plus r by 2, which will give me the mid value, and we'll compare the value at the mid position with the key that we need to find. If my mid value's position is bigger, will move my right pointer to mid, or if my mid value is lesser, will move my left pointer to the mid. So this is how we do the simple binary search approach. Now the same thing we have to apply over here also. So what we'll do, we'll simply take a left pointer here and right pointer here. Let's assume for now that we have to find key element 2, not 15, 2, and then we'll take 15 also. So we can see that we have to. Now what we will do, will let me write the indexing 0 1 2 3 and 4. So these are my indexing. Let's take it a black screen. Now what we'll do, we'll simply find the mid. As we what we do in binary search approach, we'll do the same thing over here also. So we'll do left plus right divided by mid divided by 2, which will give me 0 plus 4 divided by 2, which give me nothing but a 2 index. So the index we got mid over here. Lalit Kumar, can you try to solve in Java program? Yeah, I can try. I can even try to solve it in Java, but I haven't tried very much in Java. Maybe I think if logic is okay, then you can even code it in Java. The language doesn't matter. So I'm very much comfortable right now for in C++. Okay, I can explain the Java code, but I'm not very much sure. These questions can be solved in Java also. It's very simple, but using the data structures, I am not very much comfortable with all the data structures that we have in Java right now. But I think it will not be that difficult to solve in Java. So for now, just listen to the logic, and we'll try to code it afterwards. If you know the logic, you will be able to solve it in any programming language. It will not matter. So we found the mid. Right now I haven't created any WhatsApp group for our channel. Maybe in near future I will. So if I will create, I'll post it in LinkedIn. So you can get it from there. So what we can do is we found mid at second index. Now we need to know this mid, where my whether my value at mid is present or not. But before that, we need to figure out my whether my mid is pointing to this half or this half. There is two separate sorted half, so we need to find whether my mid is pointing to this half or this half. Then only we'll be able to uh, apply binary search algorithm, because binary search can only be applied on the sorted arrays. It cannot be applied on the on any other thing. So it can only be applied on the sorted half. So we have a sorted half as one, these 2 3 4. Now how to check whether it is sorted or not? We'll check, compare it with my left pointer, and we'll compare it with my right pointer. The midpoint values, will compare it with my right pointer, and we'll compare it with my left pointer value. Now let's compare it, the value at mid, with the left pointer value. Now we can see that the mid pointer value is lesser than the left pointer values. The mid pointer value is 1, correct? So mid value right now is 1, which is lesser than left pointer value, which is 10, correct? That means if this half would have been a sorted array, there it should be in increasing order and not in decreasing order. But we can see the mid value is lesser than this left pointer value. That means there is some rotation happened between these points, between these half. So we won't be using we won't be able to apply binary search over this half. We will only be able to apply binary search in the right half. Now compare it with the right half. We can see my value at mid is 1, and my right half, my right, let's take it, my right value is 3. Now this mid value is lesser than my right half. That means this array is a sorted half, is is the sorted half. Now we can apply my binary search on this part only, this region only. We won't be able to apply binary search in this region. So what we will do, we'll compare my key element, which we need to find, which is 2, with in this half. So suppose we'll compare my key, and this is my key, with my mid value, which is 1. Now we found that my key is greater than my mid value. That means we need to go to the right half. That means what? We'll put my left pointer on the mid value, and then we'll do the same thing. We'll apply binary search over this half. We'll find the mid value. So my binary search will again go with the same flow. 2 plus 4 divided by 2, that is 6 by 2, which will be nothing but 3. So this is my third index. We are talking about the third index. Now the third index, we went to the third index, we checked the value. This is the key that we needed to find. So we return true from here. Correct. Now suppose my key element would have been 15. So we needed to go to the left half. Now how to do that? So earlier when we found mid, my left pointer was here, my right pointer was here. Now we compared mid with my left pointer, whether this is sorted half, no. We compared mid with right pointer, whether this is sorted half, no. So this half is also not sorted, this half is also not sorted. This half is sorted, sorry. This half is sorted, so we'll compare my value, whether 15 is within this range or not. If it is not, we'll move my right pointer to the mid directly. So we'll check 15 is greater than mid. Yes, it is greater than mid, but whether it is lesser than right or not, lesser than or even equals to right or not, but it is not. So what we'll do, we'll simply move my right pointer over here, and we'll again do the binary search over here. Now again we'll find mid. 0 plus 2 divided by 2, that is 1. We'll find 1. We'll check whether this half is sorted. Mid, this is my new mid, whether mid and right is sorted, or whether mid and left is sorted. Whichsoever will be sorted, will find, try to search my key over there. So this is the logic how we will be able to solve this question. So let's try to code this half. Okay, it requires sign in. Okay. So what we will do, we will declare our left pointer as low, which will be at 0, our high pointer as high, which will be at arr dot size minus 1, last value. Now while my low, it will be same as my binary search. Low is lesser than equals to high. I'll find mid. Mid will be nothing but low plus high. Divided by 2. This will be my new mid. Now I need to compare which half to go for. Whether this mid is lying in left sorted array, or in right sorted array. So we'll compare it with left and right. So if my ARR of low value is lesser than or equals to ARR of mid. Now let's suppose if ARR of mid is the key, we'll simply return mid, because we need to return the index, correct? If not, then we need to handle whether to go left or whether to go right based on the conditions. So ARR low is lesser than equals to ARR mid. Okay, so if my low is lesser than or equals to ARR of mid, that means this half is sorted, so I will go inside this. If it is not, then that means my right half is sorted, so we'll go on the right half. So we'll on the left half, we'll check whether my left half is sorted, whether my key is present in this half or not. So checking the key, whether key should be greater than or equals to my ARR of low, and then key should be lesser than ARR of mid, because we already compared the equal to value over here, line number 12. So we need to only compare with lesser value. If key is lesser than mid value but greater than or equals to ARR of low, that means we need to search in the left half. So we will move my high pointer to mid -1, else I'll shift my low pointer to mid +1 directly. Now else, in else will, we know that this half is not sorted, this half is sorted, so we'll compare whether my answer is present or not, whether my key is greater than my ARR of mid, and then key is lesser than or equals to ARR of high. Correct. If that is the case, we'll move my low pointer to mid +1, else we'll move my high pointer to mid -1. Simple. And if we didn't get anything, we'll directly return -1. So where should I run this? Where is the run? Where is, okay. Let's see. So this test case passed, we got the expected. Now let's submit it and see whether any of the test cases failing or not. Solution accepted, correct. So all the 11 test cases passed with binary search approach. So this is the how we'll be using binary search on this rotated sorted array. We just need to figure out which half to go for, and we'll do the same thing which we used to do in the binary search. So this is the same as binary search half, just we need to figure out which half we have to go for. Okay, great. So we were able to solve this question. So this sequences, in this we solved one question. Now let's just jump to second half data structure, and we'll move in order ways. So you can also try this question. I'll try to paste all the question link in the chat. Maybe that will help everyone to open that question and solve also. So let's copy this and paste it in chat. You can also try this question. Now let's jump to the next question, which is minimum window substring. So this is data structures. Obviously we are solving data structures, so this is data structure only. Okay, no problem. So it's saying that we are given an array, find the length of the smallest subarray in it, which when sorted will sort the whole array. Okay, so it is saying that we need to figure out the smallest subarray in it, which when sorted will sort the whole array. And we have to return the length. So we need to find the length of the smallest subarray in it, which when sorted will sort the whole array. Okay. So the given array is 1 2 5 3 7 10 9 12. 1 2 5 3 7 10 9 and 12. Okay, so we need to figure out how we'll be able to solve. So one way that we can do is simply sort this array and keep it in some separate half, like 1 2 3, there's no 4, still 5, no 6 7 9 10 and 12. So this is my sorted array, correct? Now we'll compare where it has uh, where it is not same. So we can see 3 and 5, they are not at good positions. So we'll pick this part, means this is my left pointer, and from right also, if we compare, these two positions are not same, so this will be my right. So if we check 1 2 3 4 5, this is the total length that we have, correct? So the time complexity that it will take is O of n log n. The space complexity it will take is O of n. This is what the time complexity and space complexity is for this. Okay. Now, can we optimize the space complexity and can we optimize the time complexity? Which one can we optimize? Either we can optimize the space complexity, either we can optimize the time complexity, or can we optimize both space complexity and time complexity? Can we do it in O of n? That is my question. Now, I have to figure out my left, and I have to figure out my right. Now, if we see 1 2 5 3 7 10 9 12, if we see where it is deflecting, so let's consider the second example, like 1 3 2 0 minus 1 7 and 10. Now if we keep something, we need to find the smallest value, the largest value. and something. So what my mind is going on, we can even use a stack uh, for this, which might help us in solving this question. So what this question will do, what this stack will do is it will keep in sorted order, in increasing order. Whenever we find a value which is lesser than the previous value, will pop all the elements behind in the stack which all are lesser than this, which all are greater than this value. Okay, so we pushed 1. The next value is greater 3. Next value comes as 3, which is greater than the previous value, so we'll directly push it 3. The next value which comes is not greater than the previous value, it's smaller than the previous value, so we'll pop this element. Now we compare 2 with again with 1, whether 2 should be should be greater than the previous value. So 2 is greater than the previous value, so we'll push 2 here simply. We'll move 0. Now we check, compare 0 with 2. This value is smaller and the element value is greater. We'll pop this also, because this is also smaller and greater element. Now it has nothing, so I'll directly push 0 over here. Now -1 is also smaller than this value, so I'll push -1 over here. Now comes 7. 7 is greater than -1, I'll push 7. 10. 10 is greater than, I'll push 10. Now 0, 1, 2, 3, 4. Now the -1 value, this is the smallest value, which is over here. This value indicates that this value should be at position 0. And if we do the same thing from right also, what we will do, we'll take this 10. If the value is decreasing, it's fine. Oh, 10, 7. Then comes -1. Then comes 0, which is greater than -1. So I'll remove this and I'll push 0. 2. 2 is which is greater than 0, so I'll push 2. 3. So this position value should contain a value 3. Okay. Can we do it with a two pointer approach also? Is it possible to do it? We found that this was increasing, 1 and 3 was increasing, and 2 is a point where there was one downfall. So this is the position where we have to do something. So we fixed this position from right also. 10, 7, minus 1 was okay, 0 was deflecting. So this is the position that we need to do something. These are the two positions that we need to do something. So find the minimum value. So from these two positions, inside these two positions, and I'll find the minimum and the maximum, and where I can fit those two values, I'll just figure out. So from here to here, I'll find the minimum value, which is -1 over here, and the maximum value, which is 3 over here. Now I'll go with from left for this -1 and find the position where I can fix this, and from right I'll go to uh, move with 3 and find a position where to fix it. So these are the two positions that will get left and right, and will return the length of this left and right. Correct. So yeah, I think this will be the solution how to approach this question. Why do I have to apply bits again? Can't you do it on yourself? It's fine. Okay, so we have to return an integer length. So first we need to find the 2 points where they are deflecting. So low point will start from 0, my high point which will start at arr dot size -1. These are the two positions where we will start from, and after this we will move from int I is equals to 1, I is lesser than arr dot. Now if arr of I value is lesser than arr of I minus 1, that means the new value is lesser than the previous value, then there is some problem. So I'll set my low to arr of I minus 1 and will break from here. Maybe we'll break from here. Okay, so for int same thing, I will start from arr dot size -1, I will go till 0, minus I, so it will start from 2. We'll find the high position. So my high position will be if arr of I is greater than arr of I plus 1, means 0 is greater than its previous value, then there is some problem. So we'll put my high pointer at arr of I plus 1. So we found the first deflections from left, from right. Now we need to find the smallest and the largest in this deflection. So we'll start from int I is equals to low, I is lesser than equals to high, and we'll go plus plus I. Now we need to find low element, low LE, which let's take int max, and high element, which will be int min. So do we need to find the lower element index? No, we need to find the lower element. So low LE will be minimum of low LE, or ARR of I. So this will find the lower element. Now high element will be high, LE will be my maximum of high LE, and ARR of I. So this will give me the lower element and the higher element, and now from left position we'll start iterating again. L answer maybe, which will be 0, and right answer, which will let's take ARR dot size -1. So what will happen now? I need to find whether this value is at this position. So I need to find if ARR of I is greater than, if ARR of I value is went greater than my lower element, then this is the left position. So L answer will be updated to I. I might break from here. Now the same thing, my high LE. For my high LE, I'll start from now if my ARR of I, if my ARR of is greater than high LE, from behind I'm checking if no, if it is smaller than high LE, goes smaller than, if it is even equals to, I'll not do. So my R answer will be I, and I'll break, and at last I'll simply return my R answer minus L answer plus 1. There are lots of small for loops. I think I can even reduce these for loops. I don't require, there are lots of for loops. I might combine these two for loops together, or something like that. Let's see. Uh, 24. Oh, I made it low LE. Okay. uh, so my output went to 7. It should be 5. Okay, let's see. For the first case, what we did is we have 1 2 5 and 3. So this is the position, so 0 1 2. So my low will have 2, and from right lesser, so this is greater, so I'll pick this index. So my high will have 0 1 2 3 4 5 6 6. My high low will have 2, my high will have 6. So now from 2 to 6, I'll find the lowest element and the highest element. So the lowest element is 3 and the highest element is 10. So I'll find the actual position of these. So these, the value which is greater than, if ARRI is greater than, this is the position where my L answer will be there, and my high is if ARRI is lesser than my high, so my R answer will be here. So these two will be R answer minus L answer plus 1 and 2 3 4. It should return 5. Did I do any mistake? If ARRI is lesser than ARRI minus 1, if ARRI is lesser than ARRI minus 1, oh okay, sorry, I have to put I minus 1, not the value. I need to find the index. Correct, this time it's correct. Let's submit it. So if let's take it ARR dot size minus 1 on this, maybe let's take it -1 and -1. So after finding this, if low is equals to -1 or my high is equals to -1, I'll return 0. That it means it is already sorted. Use example test cases. Accepted. Okay, so this is not that difficult question, but we need to figure out how to approach this question. So this was a really nice question, how we were doing all those indices part. I'll just explain you once more how we did this question. we needed to find the smallest subarray in which when sorted, and if that smallest subarray is sorted, we'll get the whole array sorted. Correct. So in this case, what we were doing is, what we did is, we figured out what positions do we need to do the changes. Now I can see in this array, if I take this array, I can see there is the it if this array would have been sorted in order, then the graph should must look like this, or something like this, or anything like this, which is increasing, which is not decreasing, right? So we found a position where it is violating this thing. So 5 and 3 is a position. From left we can see that 1 to 5 was increasing, but 3 is a downfall. So we'll find that position. So we figured that this is the position where we saw the next value as a downfall. And from right also the same thing. From right, if we are comparing, it should decrease always, it should not go increasing. So from right we checked that this is the position that it is decreasing. So this is actual position where need to do something. So we found these are the two positions that we needed. So inside these two positions we find the minimum and the maximum value, and these two minimum and maximum value needs to be placed somewhere so that this array to be sorted. So we can see this 3 should be placed here, this 10 should be placed here, and the array is sorted completely. So 3 to 10 is my array. Okay, so this is how we solved this question. Okay, now let's take a 10-minute of break, and after break we'll be back and we'll solve more liquid questions. Okay, see ya in 10 minutes. I'm back. Let's start. Let's solve few more DSA questions. Okay, so I'll paste this also in chat. So minimum window sum string solved. Now let's go for non-linear data structures. There are a few hard questions also. I don't know they are in sequentially of difficulty or just random splitted. Let's see. Let's go for decode, encode, and decode. And let me change it. Let's okay. So the question says that we are given a list. Your task is to develop two functions. Okay. One that encodes the list of string into single string, and another that decodes the resulting string single string back into the original list of strings. It is crucial that the decode list is identical to the original one. It is given that you can use any encoding technique to encode list of string into single string. Given a list of string, your task okay uh, one that encodes the list of string into a single string and another that decodes the resulting string single string back into the original list of strings. It is crucial that the decoded list is identical to the original one. Correct. Encoding technique to encode the list of string into single string. When we encode input string apple banana, we get a single encoded string. Decoding this string should give us the original list apple and banana. Okay, it'll let me open this in lead code where encode and decode string. Okay, it's a premium one. Um, mm, 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 mm. Okay, So same list of strings will be given to me in encoding. I have to encode it and I have to decode it. So I have to keep it somewhere where I will be keeping it somewhere where I need to, where I don't get O of n time complexity. So suppose this is my lint code love you. So these are the strings that are given. I need to convert it into some simpler version of this, uh, for the code also, for love also, for you also. So I need to convert this into more simpler version of this, and after converting it into much simpler, I'll just use a hash map to keep it as a key and value. So every key will return some value. Like it might be possible that love will come again, so it should generate the same key. It should not generate a different key. The key should be same because they are being repeated. So I need to figure out, there might be many possible solution for this. How can we think of applying a random algorithm, giving it this value as this as a, this value is b, c, d, e, is not going to give me an optimal answer, because there'll be lots of strings then again. So this will always generate a only, and if further one more lint comes, it should generate a only. It should not be generating some other value. For that I can check in map, the key is present on the, but we need to find the key. We need to find an algorithm which will give me something unique for each of the different strings. Now how to do that? Yeah, this is a nice question, nice and trick question. I have to figure out how. There are many algorithms to compress, encode a single string. I can go with any of the algorithm. Encoding of a string algorithm, encode string algorithms. URL encoding, hexadecimal encoding, encoding hash functions. MD5 SH 256 encryption algorithm, AES, RSA, Blowfish. There are many algorithms which, but studying all those algorithms like converting represent binary data in ASCII string format. It's commonly used for encoding email attachments, images. Okay, I can even convert it into base 64. Encoding and decoding. Might be many possibilities for this. How to think of anything. Append string length. What type of encoding he used? Append string length. Okay, he added string length and then a colon and then string itself and then hash hash. What? It's a O string stream. What what is this O string stream? I haven't heard of this. O string stream. C++ maybe. Uh, some information when my toString method is called, which include an integer. Because you are declaring the class O string buffer, and I'm inserting inside this buffer this product name, this description, that's unit left, this on hand price and everything, and I'm returning that directly. Okay. So here also it is inserting in this OSS s dot size colon and hash hash. And while decoding part, what he is doing, he has a string of result. I is lesser than s dot size. Delimiter s dot find. Okay, the same string came here and I need to decode it back. Okay. decoded string came here and I need to decode it back. So I found the position of this, which will give me the length. So this delimiter before this will be length. So we found the size, we converted into integer uh, from this delimiter. Okay, fine, we found the size. Using the extracted size, retrieve the actual string and add the result vector. Now result, I'm adding the result into okay, just a second. Okay, it's nice. So what he is actually doing, this is really nice. I'll try and explain you what the actual question is. So suppose there is apple, there is banana. So we have apple, we have banana. So this is coming in a list, a vector, apple and banana. After I I need to encode this, store it in a string. Like suppose I have a string as answer. So I'll have to hash it out some way and store it in my string. Now I'll have to hash this again banana and store it after this answer. Again, if there were some more options like sun, moon, star, and whatever coming, so I'll have to hash this also with a separation and store it, and hash it with store it. And in the resultant, while decoding, it will give me this resultant as an answer, and I need to decode it back to apple, banana, sun, moon something, and I'll have to return it in my vector of string. This is what actually the question is, and this is how I have to figure out how to solve it. So what actually mm, he did was he had two things, apple and banana. Now what we will do in this case, we will find this apple. What he is doing is adding a size of 5, 1 2 3 4 5, which will give me what's the length. Now is appending a hash and then apple, and then he is appending a double hash, and then again banana. Banana will have 1 2 3 4 5 6 length as a single straight line, and then BANA banana, and then double hash. So now what the output will be, when we'll get this string as a decode part, will find where the first occurrence of this is happening. So I know this. I'll just move to the previous index, and I'll find the uh, substring and converted it into integer. So now I know there is a length of 5 after this, which I need to fetch, which is my actual string. So I fetched apple, and I stored it in my resultant vector. And now hash is something which is separating the two different strings. So I'll jump from here to the this part, again finding a new slash. I found a new slash. So from here till the previous substring, I'll convert it into integer. I'll find the length and I'll do the same thing. Why my eyes are itching. Just a second. Okay. So we have to do something like that. Why we are not using we can simply remove this. There was option to change all occurrences. Nice. So this O string was coming into picture. O string stream buffer. Now how this O string stream buffer is working, that I need to know. This part is fine. This is just adding or concatenating, and at last we are just returning. Now how we are doing what O string, now simple string and O string stream. What's the difference between them? Is there anything beneficial which is giving me O string stream? What says string? Let's see, is there anything? What are string streams and differences between O string stream, L string, I string stream, string stream? String stream is used to deal with both input on and output string. String stream with operator this, which is used for inserting, and this, which is used for extracting data. Name, it is appropriate for output and it only uses this operator O string stream. It is better to use to get clarity about what you want from your code. L string stream is again a simple logic. It is used for input operations, and this operator is used for extracting data. So string stream is a superclass, and O string stream and L string stream comes inside that string stream. And in this string stream I can use both extraction and insertion and extraction operator. Let's try this O string stream, how to work with this O string stream, string stream. It's very tongue twister in C++, how to use it. Add a string to the string stream. Read something from string stream object. Let's see. So I have a string str, string stream s will have this str, string word. So this is extraction. Is there anything else? String stream ss, and we are adding st to that. This, and this is string word. Now from ss we are extracting every word into word. Now fw of that word we are increasing the frequency for 1 gigs to I. Okay, so even I can directly use string stream for that. In that case, where I'll insert and I'll extract, that will be very easy for me to, that will be very easy for me to solve this question. So string stream, correct, string stream. So let's see, and I'll try with o string stream also, that strs dot size plus plus I. I'll iterate over each and I'll insert it into my result. Result insert stars of I. Correct. Now while returning, I need to return. So this, okay, I'll get a string only, not string stream. Okay, so even if I get a string stream, it will be converted into string only. So I need to figure out whether how to do it using string only. Okay, for that, in that case, we are using this o string stream, because I'm just wasting a simple operation. Or even I can use I string stream, input string stream. That will also not affect. Okay, so now I have to do it something like this, because it will be afterwards converted into string only. So I have to you I think you guys can also try if you want. This question is really nice, how we are handling the string conversion, and this is very basic uh, question or frequently question asked in Google. So let's take CULT result. In this I'll input my strs of I dot size, separating, also adding a plus to this, then add no, not adding a plus, maybe let's go this only, then adding a then adding direct strs of I, and then adding something, some delimiter which will tell me where to separate. So maybe I can keep a delimiter as comma comma. We'll do a hash or a comma. Will work. So this will convert, and now we are getting a string. this same O string stream is now converted into string. Now I have to apply all the methods of string. So there must be a string find method. String find C++. From some specific position, I need to find next occurrences of geek. Okay, find first occurrences of geeks. I found the first occurrences of geeks. String dot find. Now str dot find. What is this? ARR. Note here we pass geeks as C style string. Correct. But why? Why C style string? These are the two parameters, position and count. This particular overload but cannot be used. This will only match 3 characters from start of hello, so we'll get only 4 bytes as the output as opposed to 5. Let's now look at some examples. This is my target string. Substring dot length is 0. I'll see out. Okay. S dot find. I have to find this after this position. And from here to here I'll convert it into substring, which will give me size. So it's not I have to find a character, and from where I have to find, I'll have to pass that also. That is simple. Why everyone was confusing so much? So let's take a for loop of int I is equals to 0, I is lesser than should I increase my iterator, or should I increase my iterator twice? Plus I, let's increase it for once. Let's see what will happen. Now the first thing is find the position. So int delimiter, my delimiter is s dot find. S dot find what to find. I have to find this delimiter from this position, so it will give me the index of that delimiter. Now the size size will be nothing but string to integer. I have to convert string to integer, so I'll use stoy. Stoy will do what? S dot sub str from I of length delimiter minus I, because I don't have to add delimiter, so I'll not add +1 over here. So I converted into string. I got the size. Now from here I need to find the string. From string will be this position is I is position where so I have to increase my position, maybe I plus plus. Now s dot sub str from I of size. It will give me, now I'll push it in my result. Now I will be increased with size. Suppose is 3. So I plus is equals to size directly. But if I am increasing I dot size, it will increase from here. I should not increase from here then. Maybe let's see if I'm doing something wrong in this case. Maybe it will go TLE. Will it? So I cannot change. This is what we have to do. O string stream. O string stream. Will I be able to run now? Means I'll have to keep as it is. So, okay. Restore it to default. No. Paste it somewhere. Let's restore it to default. We are using bits. We are this plus, but using names please std should be there, yeah. So std o string stream result. Now, oh, it's saying o string stream. We not able to convert o string stream. Okay, dot str. That's why it is converting it into dot str and then returning, because the o string stream cannot be converted into string. It is saying code dumped. That means runtime error. What story? Okay, std colon colon story. Everywhere I have to add this. Come on, story simple. Just adding. I added std, right? Std colon colon story. Did I did I do something wrong? Mm, I found this. I added a story from I position to delimiter of I. That this is also fine. Now my delimiter I. So my I is still at 0. From I to delimiter of this. So I'm finding my substring from where I need to place I somewhere. From delimiter, from delimiter plus 1, and I will be added with delimiter. plus size I is equals to I plus delimiter plus size. It should be delimiter plus 1, right, and it is so delimiter is already giving me the position, and then plus size. And I need to add 1 to it because I'm adding a comma, so that will be handled by plus I. Why story again and again? Does it return size underscore t? Sorry, story doesn't return. It converts to integer. Terminate called after throwing an instance of argument is invalid. Means whatever we are passing is invalid. But why? We are not passing something which is wrong. Can we print? Okay. Let's simply run this. I got a wrong answer, but what's the result? It's 5 apple, 6 banana. Correct. So it's giving me correct output. So this is correct. There's no problem in problem here. There is some problem over here. What? I is starting from 0, I is lesser than size. I'm increasing my I. Delimiter is nothing but s dot find. I'm finding this half from ith position. That's what it means. S dot find this from ith position. I'm converting this size into integer. So from I to delimiter minus I will give me the integer. What is this? It is giving answer. I found a delimiter with s dot find. This will give me a delimiter. Now why this string dot integer is throwing error? From I to delimiter minus I. This should be there. Where it is starting and where I'm getting the delimiter minus that position will give me a string which needs to be converted to integer and which will be my size, and the new string will be delimiter plus 1 and whatever the size of the string, and I will be added with delimiter plus size. There should be no problem in this. Let's do one thing. Let's check. Let's not convert it. What even we are getting? Are we getting the expected? No match for operator plus, where I added plus. अच्छा. Size dot size. I only printed size. But why it came these things also together? So first time it's 5. The second time it's ppl comma 6. Third time it is comma. Oh, there is some problem. So first time it is coming correct. The second time, what happened? We have apple and banana. Our string is something 5 hash apple comma 1 2 3 6 ish uh, banana. This was correct, right? So my I is here at 0. Now my delimiter which where I found this I will be at 1. So my size is sub stri minus delimiter minus 1, which is nothing but this 5. So it printed 5. Totally correct. Now when I updated this delimiter, means I is equals to 1 plus oh 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 oh, what a silly mistake. What a silly mistake. But nahi, but still this size is what? This size is nothing but so size ठीक है दीदी, thank you. stoi, this is my string to integer. Let's run this. This is very bad. Why why this is failing again and again? It is not able to understand what this stoi is. So this is not my problem. This stoi is not able to understand this. String to integer. I added bits also, correct. Is there anything? String to integer. Since first time it came was correct, the second time it came is comma 6. If I add plus 1 here. Okay. So that means it will be int. Okay, that was my mistake. This I haven't added 1 plus 1 to it, so that is the reason it was throwing this error. I had to add plus 1 also. Okay, finally. So it's submitted. It's a good question. If you want to try, uh, I think I have given the question link in the in the chat box. You can go ahead and try that out. It's a good question. What we were doing, we are not actually doing very tricky thing over here. We are just adding this size and comma separated, and after getting a string, we are just decoding it based on the string size and all those things. So it's fine. Okay, great. It took a lot of time for me to solve this for the first time. I i hope this will not take this much time to solve for the next time. The only mistake that I was doing is this part. Shouldn't be doing that. Okay, fine. Okay, let's take a 10 minutes break, and then when we'll come back, we'll solve more questions. We'll be going with more data structure and alien dictionary. Okay, let's go. We'll be back after 10 minutes of break. Okay, so let's start. Let's jump to the next question. Blind 75, which is nothing but alien dictionary. Have I solved this alien dictionary before? Let's see. Alien dictionary. Oh, it's also premium. Okay. So I think I'll have to go in design gurus only. Okay, so let's see what this question is given. The question is saying there is a dictionary containing words from an alien language for which we don't know the ordering of the letters. For which we don't know the ordering of the letters. Write a method to find the correct order of the letters in an alien language. It is given that the input is valid dictionary and there exists an ordering among its letters. So there is some alien dictionary and it has given that there are we need to find the correct ordering of the letters which are given in the alien dictionary. How to do it? Okay. Now there is something given over here is a list of words for which we don't know the ordering. So these are the list of the words for which we don't know the ordering. Okay. So the question is incomplete over here. The more explanation is given that the words are sorted in lexicographically by the rule of an alien language. So from the given word we can conclude the following among its character. From BA and BC we can conclude that A comes before C. So from BA BC, so this is a lexicographical order. That means what in alien dictionary BA is coming before C. BA is coming before BC and BC is coming before AC. See, B is coming before A, but in actual we have A B C D. In actual dictionary that we have is A B C D, but here we can see that we have B coming before A. That means B is somewhere here and A is after B, something like that. And from here I can conclude that A is coming before C. So it's something like that, and from AC I can conclude that A and C, they are not same, so A is coming before C again. So we have A is coming before C. BAB. So the actual dictionary that they have is BAC. So we need to find something before something. It's like A is coming before B in a specific order. If we are going in a specific order, remember what we did in the last patterns. We had something, if we have to find something in a specific order, we used to go with topological sort. Okay. So we use topological sort over there. How can we do it? How can we apply that same topological sort over here also? That is something we need to figure out. And if we found how to use that topological sort, so using making that topological sort is not that difficult task. It will be very easy for us to make that topological sort. So fine, let's see what can we do. So we are given BA, we are given BC, we are given AC, we are given CAB in ordering. So we have BB same, they are same, so we don't have to do anything. Let me So B, B are same. We don't have to do anything with B. A, C are not same. That means it is saying that uh, A is coming before C. Means A is before C. That is what it is saying. So we can say that A is coming before C. A is coming before C. So A is coming before C. Right. So we have written A before C. Now if we check here, B and A, they are not same. That means B is coming before A. B is coming before A and C is coming. Now here if we compare these two string, A and C are not same. So A is coming before C. We already have A is coming before C. That means B, A, C are correct sequence that we also have in our resultant. Right. Now let's check with the third example. In the third example we have CAB, AAA and AAB. This is what my string is. Now in this we can see CA are not same. That means C is coming before A in the alien dictionary. So C is coming before A. Let's color it with C is coming before A. Now the moment I found that C is coming before A, I have used these two strings, so I don't have to use anything else from these two strings. Now we compare with these two pairs. AA same, AA again same, AB are not same. So A is coming before B. That means we can write here A is coming before B, so CAB. So this is what my alien dictionary will be. So CAB will be returned in my alien dictionary order. So this is how we have to go. And there might be possible that we are given uh, some other characters also. Like D, if we have D. Okay. My pen stopped working. So if we have something A, B, C, A, B, D and A, B, D, E. something. So there is a character that we are missing. So the missing character needs to be added. Maybe I can add that character at the last. This is a separate component, so we can add that character at the last. So now we need to find topological sort. So instead of going with the alphabets, we can create a like we can give them some integer values like 0 1 2 3 dot 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 dot, something like that. So for A B C D we have 0 1 2 3 dot dot, it will go as it is. So we'll not compare with the characters, we'll compare with the integer value, and we'll create a graph. Now let's take this as an example and see what do we have any other example? No. So let's take this as an example and let's see what we can do. So we have y w x w z x w w x z z y y and z w z. Let's take the first pair. So we have y y. So y first two pairs y and w. So this is saying that y is coming before w, correct? So that means there is a edge between from y to w. Y is coming before w, so there is a edge between y to w. The work is finished for these. Now let's compare with these two integers. W and x are not same. That means w is coming before x, so there is an edge between w and x. So these two are also finished. Now let's go to the third. X are same. W and z are not same, means w is coming before z. So there must be an edge between w and z. So these two are also finished. Let's try with this. X, z are not same. That means it's saying that x is coming before z. So there should be an edge between x and z. So it's something like this. So these two are also finished. Now we are coming to the next. Z and z. Z and z are same. Y and w are not same. Y and w means y is coming before w. Y is coming before w. So y is coming before w. We already have that edge. Y is coming before w. We already have that edge. Now we got a graph. Now we need to find a topological sort on this. So we can see from y should be at first, and then we can go to w, and from w we can go to x, and from x we can go to z. So the answer should be y w x z, correct? Y w x z. This is the answer that we need to find. So this is how we are doing. So whatever the question is saying, we are exactly doing the same thing. We just have to find the topological sort using graph. So if you know the topological sort solution or topological sort, then we are very much good to go to solve this question. It will not be very much difficult. So let's create words and let's see. Let's create a graph here. So we have words, we need to create a graph. So I'll use a unordered map for this. This will be our directed graph. Let's call it G. I'll iterate over the words. I'll iterate over the words. I'll start comparing the two pairs. Maybe I'll start with 1 and take 2 string. String previous is equals to words of I minus 1. String which will be words of I. Now for I'll go till the minimum size. Whosoever will have the minimum size, so int length will be minimum of, I don't know, previous dot. If this will work or not, let's see, because the size returns something different. But we are comparing with size, so it should work. It should not fail. Okay, sorry, I got a call. So we find out. Now we'll go to j is equals to 0. J is lesser than length plus j. Now if the characters of previous of j is not equals to current of j, if they both are not matching, that means this is the position where they both are not same. So if previous of j is not equals to current of j, that means this is the position where I need to add it to our graph. So what I will do, previous of j minus a, that will give me the integer value, and dot push back current of j minus a. This will also give me an integer value, and I'll simply break from here. I don't have to move any further. So this will give me the alien graph. Now I need to simply apply topological sort. So for topological sort, I'll be using in degree I'll be using BFS, not DFS. I'll not go for DFS. So BFS approach, for BFS approach I need something called as in degree. In degree, all the characters maximum can have a 26 length, and initialized with 0. So this is the graph. I'll increase the in degree of current of j minus a plus plus. Now I'll use a queue. There's one thing that I need to make sure that I do not push in my answer a value which is not present. So I'll go with int degree dot size. I need to find if that value is present uh, in my queue. Wait, what? Wait, what? Why? What? It resetted. I cannot even undo. What the hell is this? Oh man. Means I'll have to write everything again. That's why I don't use these websites. These are really, they really give hell of a time. Or maybe I'll directly use my Sublime Text and I'll then copy paste it. Let me just copy the method over here. This will be my graph. What I will do for I is I'll start with one. Words of I minus 1. Previous is equals to words of I minus 1. Current is equals to words of I need to compare these two strings. How to compare these two strings? These two strings will be compared directly. Maybe I'll take the length as minimum of previous dot size comma current dot size. I'll iterate over j. If previous of j is not equals to current of j, that means this is the position where I need to put it in my map. So previous of j minus a dot current of j minus a. Also I'll increase my in degree of current of j minus a plus plus. Vector int, because I don't have the in degree, I can declare it with size of 26. Okay, great. So we created our graph. We have to break from here. I don't have to move any further. So we'll break from here. We'll start my topological sort. Now starting my topological sort will require some even I can go for 26 plus I. Now if g dot find I, let me convert it into character, is equals to I plus a. Find ch. No, it's we are inserting integers only. No, don't do this. G dot find I is not equals to g dot end. That means it is present, and in degree of I is 0, then we'll insert it in my queue. So I have to declare a queue over here. Now this is done. What I need to do next is we will start by while my not q dot, while q is not empty, I'll take the value and is it possible that there will be multiple answers used and ordering among its letters? There should not be any multiple answer. Even if they are, I'm not very much sure. Should it be returning less, so graphically smallest, or something? Let's see. So I'm creating my result. Int val is equals to q dot top not front character ch is equals to val plus a, and result plus is equals to ch. This will be q dot pop. Now I'll check in my graph. This is then g of val dot size. Now if in degree of g of val ka I will be reduced. Now if in degree of g of val of I is equals to 0, I'll push it in my queue. Oh my god, why I'm doing this again and again, I don't know. G of val of I. last I'll return my result. Okay. So let's create a vector of string which will be nothing but the let's take these all values, and now let's call this method find order. It will return a string answer. Find order will be given with vector string words. I'll pass this words here. Let's see. Okay. ORDERED, unordered map. Find order was not declared in this scope. Oh, it's inside a class. So I need to create an object of solution. Okay, so it's returning YWXZ, which is actually my answer. DSA and CAB. Let's try with this also. It's returning BSc and CAB, correct. So I think this is working fine. Let me just copy and paste here and run it. So it's expected as it is, but there might be something that I am missing, uh, which I think so. Let's see if correct. This is what I was missing. If there is some character which is present in our string but not in our map, I'll just have to add those characters also. What does that mean? Mm, Now, how to do this part? This should be handled separately. Um, how can we handle this part separately? Maybe I can use mhm, something, some kind of set to keep track of that, or may can we use something else? Means we have it in the string. That is what it is saying. We have it in our string, but it is not present. We can handle uh, these separately because there is no connection between those elements. Those are independently moving here and there, so that can be added any time, anywhere. For that means if that key is not present in my map, I'll just store it somewhere. Maybe if that key is not present in our map, so what I will do, I'll iterate over words. I'll iterate over each words and I'll check if g dot find words of I j is equals to g dot end, that means it is not there, but still it is there, so I'll add it simply in my result. Words of ij, and I have to keep something that this word was added. I don't have any work for g, so g of words of I j dot pushback g of Oh, bracketing mistake. Why true or false? Let me check it over here. G dot find words of ij is equals to g dot n. Oh, words of ij, it's an integer value. Why it didn't print C? Result plus is equals to words of ij. C A C A C A. And this, it's not returning anything. It should return any. Should return if they are not matching. Then we are adding in my map. Uh, uh, uh. Segmentation fault. After adding this, it is giving segmentation means there is some mistake in this. I is lesser than word dot size plus plus I. Words of I dot size. Oh wow. Now it's coming. Now let's submit and see. That are we doing any mistake? Oh, great. So the solution was accepted, and all the 9 test cases are passed. So this was a really good question for I would say for topological sort in a string. So it's really nice. You can try this solution. Maybe I'll save it with dictionary. So nice. So we were able to solve this alien dictionary. Now let's go to dynamic programming, and in dynamic programming we have a question called word break. Let's see. So the question is saying that given a non-empty string and a dictionary containing list of non-empty words, determine if the string can be segmented into a space-separated sequence of one or more dictionary words. Each word in the dictionary can be reused multiple times. Okay, determine if the string can be segmented into space separated. Okay, each word in the dictionary can be used multiple times. That means I love coding can be divided into I love coding separately. It's true. Now, hello world. We have hello also, we have world also. We have hello world also. So we can make use of these three also. We can make use of these two also. So we can even return the minimum length required to make this string. If it is not possible, return -1. If it is possible, then return something. So enjoy life is enj. If I am making enj, so we need oy life again, but we don't have oy life. We have enj life. Oy is missing. You can use joy life. We have joy life, but we don't have en. Okay, so this can be used, can be solved using dictionary, using dynamic programming. We'll have to figure out whether this string is present or not, or these strings, if it is present, then we'll call to the next index. Okay, fine. So we'll be solving this question after a short break, and then we'll see how to approach to this question. Okay, let's take a short break and we'll be back in 10 minutes. Hello, I'm back. I'm sorry, I'm eating something. Okay, let's start. Mm, okay, let's try to see how we can approach to this question. So the question says, mm, let's take hello world. So this hello world will do what? We need to we have been given hello world, hello world, hello. So in this case we need to find how we can make this answer. We'll check, we'll we'll make strings and we'll check whether this string is present or not. We'll check whether this string is present or not. We'll check h is present or not. No, it's not present. We'll make he, whether he is present in my map or not. No, it is not. We'll take hel, whether hel is present in my map or not. No, it is not present. We'll take hell, whether hell is present in my map or not. Yes, it is present in my map. So what I'll do, I'll start with another index and we'll call another recursion call from o, sorry, hell. Okay, hell is present. So o is present or not? No, it's not present. Ow is present or not? No. Owo, no. Owr, no. L, no. D, no. Not present. So we'll fall back and we'll combine again o with this. Hello is present or not? Yes it is present. So we'll go to the next word. But w will start with WORLD is present or not. So this way we'll do the recursion calls and we can see there'll be possibility that suppose this is HEL. So there might be possibility that we went to HEL and then LO, LO, LO and then world. This is one of the answer. Now we can also go from HELLO and world. So this world has been repeated twice. This is different. The first half is different. This is what I would say. They both are different from each other, but they both are same. You can see they both are same. That means there is some repetition of words happening. So here we can add some dynamic programming so that if we calculated it once, we don't have to go back again to that word and find whether that word is present or not. So we can directly do this. Okay. So this is what I am thinking of right now, and this I'll do. Okay. So maybe I'll do two things, count as well as this bool. So this will do both our part, count also and bool also. So return solve. I have a s. Now this verdict I have to keep it in my map, or set would be fine, of string auto word from word dict. st dot insert. Now don't do this again, that you reset the code at least. Okay. So I have my solve, I have my string ampersand s. I should pass in index also. From which index should I start? Index, and then unordered set of string ampersand s. If my idx went beyond or even equals to s dot size, this will be my base case where I'll be returning 0. Now there will be a for loop. I will start from idx, I will go till s dot size and plus I. Now if s of there will be two things which will be int count as well as temp. The temp plus is equals to s of I. Now if st dot find temp is not equals to st dot n, that means this is present. So I'll do a call. Count will be minimum of count comma 1 plus solve s idx will be I plus 1 and st will go as it is. So at last I'll return my count. Here I'll store my answer. Now if answer is greater than or equals to int now also I have to apply dp. So vector int dp will be of s dot size -1. I'll pass this dp, I'll accept this dp, I'll pass this dp here also. Now if dp of idx is not equals to -1, return dp idx. Let's Hey, for this also it came out to be. Oh, okay. Why? Long, 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 long. Comparison is with. This should not be the case. 3, 2, and okay. So now it's fine. Let's comment this out and let's submit and see whether everything is okay or not. Okay. I'm really sorry for my. I'm really hungry right now. It feels like I can eat anything. Okay, so we were able to solve this question also. Oh, I didn't paste this question in the chat, I suppose. I'll paste it now. Okay, so we were able to solve this. Now let's start from start and let's go to the second last question of every. If it is easy, I'll not pick that one because that will be very easy for us to solve. I'll pick medium and hard questions only. So let's see what this question says. Okay. It is saying that we are given an array, find the contiguous subarray that has the maximum product. So the input given is 2, 3, minus 2, 4. what I can think of here is we are given 2 3 minus 2 minus 4. So we'll have to take a minimum, which will be nothing but int max, and maxi, which will be nothing but int min. Now I need to find a contiguous subarray. So if we find a positive number, so maxi will be nothing but 1 multiplied by this, which is 2. So global maxi will be 2. Global maxi will be 2, and minimum will also be 2. The first value will always be the maximum and minimum. Now it comes out to be 3. So the minimum will be either this minimum multiplied by 3, or three. Whosoever is the minimum will be kept in my mini. So mini will have nothing but updated to 3. Maxi will be maximum of 2, 3 or 3. So it will be updated to 6. Now next, negative value comes. If a negative value comes, what I can do is multiply this number with -2, so my mini will be 3 minus 3 multiplied by -2, or -2. Which one is minimum? -6. So it will be updated with -6. Now if a negative value comes, there is something which I can do. Which is nothing but maximum multiplied by minimum multiplied by this number, means maxi multiplied by -2, one possibility, or mini multiplied by negative 2 another possibility, or negative 2 the third possibility. These are the three possibilities. For max C, what are the three possibilities? Max C multiplied by minus 2, mini multiplied by minus 2, and minus 2. Out of these three, whosoever will be maximum will be kept in our answer. So I think this will give me the optimal answer for this question. Okay, let's try and solve it. And stop size plus plus max product is equals to nums of 0 currently. So what I will do, inside temp I'll store my maxi, and maxi will be nothing but a maximum of three things: maxi multiplied by nums of I, comma, mini multiplied by nums of I, comma, nums of I. Now if 0 comes, 0 arrives, that will break everything. Mini will be minimum of so instead of maxi it will be temp mini into nums of I or nums of I. Now if nums of I is equals to 0, maxi is equals to 1, mini is equals to 1, and maximum product is equals to maximum of maxi, mini, or 0. Out of these 3, and I'll continue from here, else every time run. What? Max product is equals to maximum of why it's it is maxi minus mini. Why it's coming out to be -1? And why the first answer is 4? I started with 1. Max is equals to maximum, that is through 2 into 3. 6 mini into the 3, 6 or 3. So maxi will be updated with 6. Max product is equals to maximum column mini. Oh, it should be max product also. Let's submit it and see if I know it is accepted. Great. So all the test cases are passed, and we have successfully solved this max product also. We needed to only handle this extra case. If it is 0, okay. I'll paste this into chat. Okay, so I think I'm feeling very much hungry, so I'll take a break and I'll go for a lunch break, and when I'll be back, I'll start solving more questions. Okay, so I'll be taking a break of hopefully 1 hour because I have to order food. I haven't ordered yet. It will take 30 minutes to order to come, and then I need at least 30 minutes to eat. So I'll start my timer, and I'll be back in 30 minutes. See ya. Hello guys, I'm back. Let's solve some more questions. So last time we solved word break. So now we'll be solving few more. Okay, let's start with Pacific Atlantic water flow. I've already solved this specific, so I'll not solve this again because this is really what should I say, lengthy question. So it'll take a lot of time. The only thing is the concept. So if we know the concept, we'll be able to solve it very easily. So the concept says we have a Pacific Atlantic water ocean, and we need to know how many um, what all lands. Let's read this out. Okay, the Atlantic Ocean touches these two sides. The Pacific Ocean touches these two sides. Now the island is partitioned into grid of square cell. You are given m cross n integer matrices heights. And these are the heights above the sea level. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from it. So if there is a rainfall and if it falls on these grids, it can either go to this Pacific Ocean or it can either go to this Atlantic Ocean. So we need to find all those islands which can go to this Pacific Ocean, this Atlantic Ocean, and we have to return the coordinates of that. So in this case we are just using the recursive approach. We are solving it using recursive approach. We have a Pacific grid and we have an Atlantic grid, and from here I am going to these so I am taking two grids like this water and this water level. These are going to Pacific, these are going to Atlantic, and these are going to be Atlantic, and these are going to Pacific. So all the boundaries values I'm taking, and we are going to the maximum portion where we can go. So we'll reach out to these positions from these 4 solve methods, and after that I'll just check whether the values we reached is equals to -1 because else rest of the values will not be -1. They will be filled up with some other values. If it is -1, we'll push out. So this is very simple. This is not a difficult question to go for. So it's fine. I will not be solving. I'll just paste this solution into the chat and you can try the solution. Pacific Atlantic water flow. Binary level order traversal already solved using BFS in the patterns that we used. So this is also not very much difficult. I'll just paste it in the chat and you can. Let's jump to number of connected components in undirected graph. Okay, let's see this question, what this question says. So we need to find the number of unconnected components. Okay. So this can be solved using using union and find method very easily. So we are given an edges, we have an input n is equals to 5. So two components are 0, 1 and 2, 3, 4. So 0 is connected with 1 will unite these two, 2 is connected with 3 unite these two. So it's a simple parent count, will count the number of parents and easy. So this is simple union and find question. If you won't be able to solve, let me know. I will try and solve these questions again. Jump game. I have already solved this question, so this question is just let's think over it. So I'm at index 0, the maximum that I can go. The maximum I can go is 0 plus 2 is max. From here I can go is 2. From here I can go is 3. So the total number of jumps I need to count. So count will increase when we reach, and then we'll go to that part. Okay, let's code this out. It will not be that much difficult. So and jump if an element is 0, then we cannot move through that element. Write a program to find the minimum number of jumps needed. And jump and global max will be plus I. Now if global max is equals to maximum of global max, or I plus jumps of I. Now if curve max is equals to I, and then I is not equals to jumps dot size minus 1. So we'll update my curve max to G max, and jump count will be increased. and finally we'll return jump, total number of jumps. Let's see, use example test cases. Oh, so it's 3 4 5, it's fine. Let's see if I'm able to submit. Okay, this solution is accepted. Great, so this question is not also very much difficult. I'll paste this also in the chat, you can try. If you'll have any doubt, let me know. I'll explain this. So all the tools are finished. Let's start with backwards and then we'll go to forward. So the given question is, given a 2D dimensional grid of size m cross n, where m is the number of rows and n is the number of columns, you need to find out the number of unique paths from top left corner to bottom right corner. The constraint are the okay, this is also a DP problem. We are given a grid of 3 cross 3 and we can either move right or we can either move down. So this is just, I would say, so from here I can move right, I can move down. So these are the two positions that I can move. It's a recursive call, and if I reach this position I'll return 1, which will be added. So this question is already, I have solved this question, so I'm not sure if I am going to solve this question for now, or because these are not very difficult questions. Okay, so unique path, graph, valid tree, given a number n in which indicates the number of nodes numbered from 0 to n minus 1 and a list of undirected edges for the graph. Determine if the graph is a valid tree. It has no cycle, it is fully connected. So for no cycle there is a DFS approach to figure out whether there is a cycle or not. If there is a cycle, it will return that there is a cycle, and if it is not, we'll just return the number of counts, total counts, how many are there, total counts are there. If the total counts here is greater than, is not equals to so from any node or even maybe we can make a union and find. So for in union and find, how we'll be able to make sure that They are not, they are cyclic or no cycle are there? Will it be possible to figure out the cycle and not cycle? A graph qualifies as a valid tree if it meets the following criteria. It has no cycles. It has fully connected. It is fully connected. Example 1. Total input is this. Zero to one, one to two, two to three. There is not self loop, but 4 is not connected, so it will be a simple DFS call. Valid will be, so I'll start from 0, I'll iterate over all the elements, if the and return the count, and if I somehow reach to an element which is already I have visited, which I already visited, then I'll return. Okay, so this is not a separate one which I was thinking detect a cycle. This is very much similar to normal graph traversal. If I reach to the node again from any different node, then that means uh, we have detected a cycle. So this is very much similar. I'll just do a DFS. Should I solve this? Let's just take a boolean cycle is equals to false. Cycle will be false. I'll do a call. Okay. This is my n, this is edges. And it will return count. Now if count is equals to and return so before that I have to create a graph. Vector and G will be of n size. Now if form is equals to g of from push back to so this will be my and solve. I'll pass this g over here. So what all things I have, I'll start from zero, from anywhere. Number from and a list of undirected. It's an undirected edges. So it will be g of determine if the graph is valid tree. Oh, to determine if graph is a valid tree, what can we do? I need to keep track of the previous node from where I came, because if we don't know the previous node, we might end up in going to that node. So what can we do? I need to keep track of a visited array so that I'll get that if my array is visited or not, which will be of size n and initialized with -1. So when I'm calling a solve, I might start with any of the index. So this is current, this will be my previous, this is my graph, and this is my visited. So what all will be accepted in 10? No. N is nothing but current node, and this is my previous node. This is my graph. Should be %. And this will be fine. So in this case, if if visited not visited of current node will be marked as 0. Now this is my g of current node dot size plus I. This will be my new node. New node is current node of I. Now if new node is not equals to current node, it should not be equal to means from 0 to 2 should not be equal to the previous node. If the new node is not equals to the previous node from where we came, there is one thing that if a visited of this new node is not equals to -1, that means there is a cycle. Cycle is equals to true, or even I will just return true that there is a cycle. Else I'll else if whatever solve is so the current node will be my new node and the previous node will be my current node. Graph will go as it is, visited will go as it is. If it came out to be true, I'll return true. If it is false, then I'll go move forward. So now it will return some boolean value. If a result is equals to true, then return false. Else for int I is equals to 0, I is 1. If visited of I is not equals to equals to -1, then return false, else return true. Okay. So true, false, false. Second is also a loop, third is disconnected. Perfect. So the solution is accepted. So this is simpler, not very much uh, difficult. Same tree, it's easy, so I'll not go with this same tree. Palindromic substring. Let me check. And group anagram. So given a string, determine the number of palindromic substring present in it. A palindromic substring is a subsequence of character that reads the same forwards and backward. The substring can be of any length including 1. Input. Okay, I have to determine the total number of palindromic substring that are possible. For once all the single character digits will take place, there is a CEC, फिर ACECA, फिर RACECAR. So total of 10. Noon is equals to NOO so I is a short length 1000. S consists of lowercase English letters. So how we will be doing this? Okay. So I need to find total number of palindromes possible. So one thing is generate all the substring and compare all the substring whether it is a palindrome or not, or so it might be possible there is some some race car RS. Okay, so race car and race car. in this RR matches, so there is one for each of the same characters, total number of one count. Now we have RA and R. What this means? This is R and this is. Mhm. So N. So let's take this as apple, APPLE, and ELPPA. Now they say DSA did not match. So we can either, if they do not match, I will jump to the next characters to compare these both characters. If they also do not match, L and E. L is here, E is here. Even if I reverse it and compare, if they are not same, I can either go to jump this as this, or remain this and jump this as this, or both. If they are same, we'll jump to next. So I can do something. Okay, let's make it simple. Let's not make it complicated or anything difficult. Let's split from mid. Take this as a character, split from here, split from here. Because we can go of n square, take this as a character, split here. Check, compare. Keep it in my answer, keep it in my answer. Increase our count. Huh? Mid splitting from everywhere. So I'll have to return count. So what I will do, I'll start from mid split. Palindrome can start from middle and then to or middle or the next character. If there are two characters which are same, I'll start from the left pointer here and right pointer here. That is one of the possible answer too. So count plus is equals to mid considering left right as the same value. So considering left as I and right as I with s as a string. And one more thing, considering I comma I minus 1 comma s. So it will return mid split if left and right string s. Now if I'll make this left as minus 1 and this as I, if L is lesser than 0, return 0, else while L is greater than equals to 0 and then R is lesser than s dot size, if दोनों case are true, if L is equals to s of L is equals to s of R, I'll increase my answer and L minus minus will do n minus minus R minus R plus plus. If not, then break. Simply return answer. So it's a 366. Let's add this race car this moon and this apple, and then run. Okay, perfect. Let's submit it. Great, this is accepted. So this way we will be solving this palindromic. Did I send? So group anagram is nothing, just sort and compare and keep it in hash map and return. We'll take analog and complexity and be able to do it. Okay, so total in total we were able to solve 3 15 questions. So right till now we solved 15 questions. We can also go for some other questions. There are 2 questions which are hard: serialize and deserialize binary tree maximum path sum, merge case sorted, find median from data stream, and word search 2. Okay, so I think today I'll stop here, because I have to go out. I have to do something, and it's already raining. I don't know when it will stop. So maybe we solved 15 questions. Next day, next week, we'll solve more questions based on these, and we'll try to find more patterns. So these were not very much difficult questions. The only interesting question that I solved today was in code and decode string. This was really interesting question, and one was alien dictionary. These 2 questions were perfectly good questions. So it was nice. And finally we were able to solve all those questions. So that's it guys for today. If you liked, do like, share, and also subscribe my channel, and hopefully we'll meet in the next stream. And in next stream I'll be streaming for 8 hours, that's for sure. Thank you very much. Thank you. Bye bye.